They're both T's.
They're both T's. I'll give you that.
Then I added the 6 and the 8, which both S's. And then I did 14 plus 9. Well, 14S plus 9T is 23.
Okay, so she said she did the T's together and got 9. And that she did the S's together and got 14. And then she said she went further and got 23 what? You got 23, right? 23 ST?
Yeah.
Okay, she was good until where?
ST.
Till the 23 ST. Is she actually allowed to combine those? Are they like terms? No, one has a T, one has an S. So she was actually done here. She went too far. Hey, she went too far. So she was actually done here. But what's great about Natalie, I've had her before, so I can pick on her. What's great about Natalie is that she shows her work on the paper. So even though she has messed up and didn't get the right answer, I can give her points for, of course, she's done most of the right steps. Okay, and then yesterday when we were, some people were going ahead and working this like they were supposed to. Some people were foiling. Why are none of these problems going to be a FOIL problem? How do you know?
Because
Yes, dear.
they have a plus or minus in between.
They have that plus or minus in between. So if we were actually doing points, I would have given Natalie's group a point because she volunteered her answer so nicely. Whoever helped me correct her would have gotten a point, and then he answered a question, he would have gotten a point. You see how we were going to be on a point palooza. And then we're going to pretend Seth's over here texting, but surely he's not. And then I would say, oh, Seth's group's lost their point because, man, we were trying to be focused, and he done got us distracted. Okay. Can someone tell me their answer for number 2?
13M minus 13M.
13M
9M.
minus 13N
I meant 9M.
9M.
Yeah, that's what I meant.
That's what she meant?
9.
Okay, so let's talk about why she meant 9. You were supposed to do 11 and the 2 go together. I give you that. And I see how 11 plus 2 is 13. But there's something that lets me know we weren't actually supposed to add that minus symbol. So I needed to do 11 minus 2 and get 9. But you were very smart enough to realize it was negative 7 minus 6 and get negative 13. So that part was good. You've had your hand raised, and I was on a roll. Yes, dear. Arturo, you had your hand raised.
I was about to, that it was about it was 1N, but I just realized this way.
Yeah. Okay, so let's talk about ways Addison could have done this problem differently. So maybe if it gave her an issue, she could figure it out. My suggestion, if these trick you when there's a minus sign, is to distribute that minus sign. So maybe on your paper you write what I'm writing in green, 11M minus 7N, negative 2M minus 6N, and then from there combine your like terms and say 11, negative 2, that's 9, negative 7, negative 6, that's negative 13. So if you can't get to the pink in your head, there's not a problem doing what I did in green and just distributing that negative. You remember your order of operations. We're going to talk about that again today. That's my suggestion if that negative sign is what throws you off. So like if you miss number 2 and number 4, you probably need to distribute the negative. Okay, do I have a volunteer on number 3? Yes, Paige.
I got negative 1E squared plus 2.
Okay, and I'm going to be super picky on her all of a second. Negative E squared plus 2E. She said everything right, and she let me know there was a 1 in front. Do I have to write the 1 in front? No. But she realized 2 minus 3 was negative 1. She did negative 5 and positive 7, and she got positive 2. And I really like that she put it in descending order, meaning that the highest exponent went first. Now, I realize at this point I'm being super picky, but they tend to go ahead and put it in that order on the ACT, so we should just go ahead and get used to that. Or descending order, not ascending. It's going down. Math. Okay, and then we get to number 4, and it's another tricky one because it's got that negative sign in between. I have a volunteer for number 4.
Oh.
I would love to hear, let me be more specific on who I want. I've had a volunteer from 2 and 3 and 6, and I think like I've heard from 1. I would love to hear from 3 or 4. Let's see, I'll be specific. Valeria's table is table 3. I need to learn some names at table 4.
Yup.
That's why I got me some popsicle sticks. I would love to hear someone from 3 or 4. Yes, dear.
I just put negative 1x squared minus 2x.
Okay, I'm just going to put negative x squared. Again, you don't have to write that one. I understand it's understood. You don't have to write it. And then what'd you tell me for the other? Minus 2x?
It'll be minus 8. No, it's plus 8.
Is it minus 8? Is it plus 8? We reached this problem. So, I don't know. I kind of want to put the plus on with it. So, again, if the minus signs are confusing you, I would distribute it and say what I'm going to say here in blue. X squared minus 3x minus 2x squared minus 5x. And then she knows for sure. I know she had the x squared minus 2x was negative x squared. But now she's positive, negative 3, negative 5, it's negative 8. So if you're questioning yourself on those negative problems, I would distribute that negative. Okay, are there any questions on 1 through 4? Okay, well now we reach the fun time in life. We're going to look at some ACT questions. And I did not think this through in advance in that I did not make, I'm sorry, it's a lot of pages of copies. I did not make copies, but I will post this sample test on Google Classroom. So if Addison has a problem and she just can't see, then she probably needs to print this at home because we're going to keep going through this test for a while. Okay, so what we're going to do is I'm going to give you, on the ACT, this is a practice test for the ACT. If you want to get out a white piece of paper while I'm talking to you, that would be terrific. Okay, so, what dear? No, not yet. We're going to work on it for a while on Monday. We're going to be on this test for a while. Okay, so 60 minutes, 60 questions. Obviously, we don't even have 60 minutes in this class period, so I'm not going to give you that long. There's strategies with the ACT we're going to work on, and I'm going to keep saying the same things over and over, but here's the first. The first 30 problems are supposed to be the easiest. There are 60 problems. The first 30 are supposed to be the easiest 30, which means we're allotting our time wisely. That's half the problem of the ACT is time management. We're allotting our time wisely. We need to go through the first 30 pretty quickly. In fact, we need to spend less than a minute per question on the first 30 because the second 30 are a little harder and we might need to give them more than a minute. We might need to give them 2 minutes. So that's my 2 cents for now. You might not know the answer. That's fine. We're going to talk about reasoning skills. Some of these topics we haven't even covered yet that we'll get to, and we'll just have to talk about how to guess because I hate to tell you this, not everything. You might not have learned something in math class. It's going to be on the ACT. It's sad but true. Okay, today we're going to do the first 3 questions. And since I'm feeling pretty sorry for you, I'm going to give you more minutes than you deserve because we are starting out. So normally you should only get, let's say, a minute for this question. And today I'm actually going to give you the full 2. Okay, so go ahead and read. You've got 2 minutes from now. You need to pick an answer and be ready to explain why you picked what you picked. Okay, does anyone not have an answer? Okay, perfect. Before we go over it, let's go ahead and knock out the next one. I'm not going to give you quite 2 minutes because it's a geometry one, so no offense, either you're going to kind of know it quickly or not. I'm just going to give you a minute on this one. I'm praying my geometry babies will remember something. Three. Sometimes we're going to do more, but we're going to take it easy at first, so my gosh. Okay, does anyone, ooh, I still got some writing. I'll let them write. I still got a little time. You got about 10 seconds and I'm moving on. Okay, and now for our last one of the day. It is, funnily enough, another geometry-looking problem. Let me see if I can get it zoomed in better on the screen. Again, if you have issues seeing things, I'm going to post this on Google Classroom. That way you can just print it off and bring it in. Like if Valeria's sitting too far back and she just can't. Okay, I was rambling, so I'll give you at least a minute on this. Okay, does anyone need, oh, yep. Okay, and I'm being nice today and making sure everyone's got enough time. I mean, eventually we're going to be like, this is how long you have. You got to pick an answer and let's go. That way we can go ahead and get used to that in life, because otherwise it gets terrifying when you take your real ACT. That's half the stress to me, is the time and the crunch of it all. Okay. I see Brista writing still, but she's always my best student, so she'll forgive me for moving on. Okay, so if we back up and go over these, go ahead and talk to your group and see what answer they put for number one. Maybe you all have a similar answer on number one. Talk to your group and see. Okay, I hear a lot of B's, some C's, some B's and some C's. Okay, stop talking to your group. Let's talk about what the real answer is. So I have a key. Of course, I can cheat. I have a key. And the real answer is C. Let's talk about why it is that. And let's talk about what's wrong with your paper from what I can see from here. A lot of people, like Miss Brista, a lot of people just have number 1 a letter, number 2 a letter, number 3 a letter. When in math class have you ever been great at math without actually doing some math on the paper? I've never been that great. I have to do math on the paper. So if we read through that problem again, it says that there are 32 people. And actually, some people got the answer. Can you tell me how you got C?
-1.
Okay, because it was 32 total members, but 5 are officers. And it can't be an officer, so we need to remove those officers. So 32 minus 5, and you do get 27. So he could be a member out of those 27 options, so it's 1 in 27. Now that makes sense. But to be honest, math teachers get in a hurry. We're trying to cram in a lot. And this is statistics and probability. And if there's a section we're going to skip, it tends to be statistics and probability. So if you don't understand it, you didn't get that one, that's something we could work on doing 0 period specifically. Like, you need practice with statistics problems because your teacher didn't spend a lot of time on it. Okay, and then what I always did in geometry was talk about, and I'm not trying to be ugly, I'm just trying to be honest, which answer up here is dumb. Is there a dumb answer on the screen right now? What's a dumb answer up here? 0 seems like a dumb answer. I mean, surely he has a chance of being a member. So I wouldn't have picked A. I wouldn't have. Okay. And there's one more answer up here that I think is kind of silly too. Okay, I think D's kind of dumb because why would they not simplify it? 6 over 32 reduces. 2 goes into 6, 2 goes into 32. So since it's not in simplest form, I kind of think that one was silly too. And I have to agree that it says he's not an officer and that there are 5 officers. So I think E's kind of silly too. So when I was guessing, like you, I was either going to guess B or C. Okay, are there any questions on that one? Then let's go to number 2. Now, I have taught geometry for the past 2 years, so I stinking love this one. Maybe you don't. Talk to your group, see what your answer is. I'm hoping you're on the same page. Okay, I hear a lot of K's. Does any group think something other than K? J? Okay, I got a lot of J's and K's. You know, back to my guessing skills, I'm kind of SOL on this one. I mean, there's no way I can say, every single one of them has a congruent symbol. A lot of them involve the letter F. A lot of them involve the letter C, so if I'm being real honest, I probably would have been not J, just because I'm going on this logic of I see a lot of letter F's, I see a lot of letter C's. Is that good logic? Nope. No. But will it work if you're in a super bind? Maybe. It's better than blindly guessing or making a Christmas tree. Okay, so it actually says that there's something with a statement, a congruent statement. Did anyone draw a picture other than Miss Rister?
I didn't draw a picture of this one. I just matched.
Okay. It's a congruent statement, and I know some of you are doubling up with geometry. You're like, I don't know what that means. In geometry, the letters, the order of the letters, let me rephrase that. The order of the letters is super important. So, for instance, letter A, it matches with letter D. They're both first, they go together. Letter B has to go with letter E. They're both in the middle, they have to go together. And then letter C has to go with letter F. So that's how Miss Brister was figuring it out. Now, does that necessarily make sense to me? No, I probably would have drawn me a picture and said A, B, C, D, E, F. And then I would have looked at my picture to figure out the answer choices. So it said, showing my picture on the screen, our options were, I don't know how good I am, our options were AB is congruent to DF. Well, AB is here, DF's down there. It was out. The next choice said AC is congruent to EF. Well, EF's over here, AC's at the bottom, it's out, and so forth. And you can go through it and figure out which one makes sense. The only one that will actually work is that angle C matches angle F, which was letter choice K. If it's a geometry problem, especially a triangle, table 1 would have lost the point now, my nerves. If it's a geometry problem, and it's referring to a triangle, why on God's green earth did you not draw a picture of a triangle? You had a geometry teacher. She drew a lot of triangles. Why did you not draw a triangle? That I don't know. You'll get better. Okay, talk to your group about your answer for number 3. Okay, table 5. What do y'all think on number 3? You're my quiet table. You got C and D. C and D. You got A? A. You got D. Someone got, there's no J up here. A. Okay, so it sounds like today, and this makes me kind of sad because, I told you I'm a geometry teacher at heart. That number 3 was the hardest one for us today because we're all having different answers. I got someone who even said J. J's not up here. He's just joking. But, okay, so just looking at the answer choices, I can eliminate one of these. Which one can I eliminate? I would eliminate E. Do you see the 5, 5, 5, 5? My processing skills tell me that one doesn't have a 5, it's not it. Now, if they had put 85, I would have been there. But they put 80. Now, why did they put 80? Because they're smart. They realized 100 plus 80 is 180. And if you remember geometry, you didn't really know what you were doing, but everything needed to be 180 or 360, and this looks like a 180 kind of thing. Okay, so what I would have done is I would have drawn, you don't actually, the cool thing about the test is you get to draw all over the book yourself. I know. So, I'm wasting time by having to draw the picture. In the real test, you can just write on top of the picture they gave you. Okay, now, for my super nerds who actually remember the names of things, which I appreciate, this was called the exterior angle theorem, that outside angle was supposed to be the sum of the two remote interior angles. Now, do normal people remember that? No. But normal people do remember what a linear pair is. And they knew that this plus this should have been 180. So an 80 can go right there. But is that the spot where the X is?
No.
So what could have happened to you is Natalie's so excited. She knows there's an 80 there, but that's not where the X is. So that's why she maybe picked E. Or she didn't actually pick E, but I'm just joking with her. Okay, and then what is the triangle supposed to add up to?
180.
180. So I need to do 180 minus 80 minus 65. Let's see, 80 and 65, they're 145. So 180 minus 145 is 35. Okay, but this paint work I'm doing on my paper, I'm doing to show you and prove a point, is still silly and time wasting. I've got this magic thing called a calculator. It can do 180 minus 80 minus 65 for me. And make my life so much faster. So the answer is supposed to be C, which is 35. So the answer is C. Now, if we're being honest, I'm not even trying to be, just being honest, and I'm blindly guessing. In my skill world, I know this, I have a weird guessing method, and it doesn't always work, but it does help me. 15 was too small. 65 was too big. We already talked about why 80 was out. I was either guessing 25 or 35 to begin with. I probably would have added 65 and 35, saw what it got. 65 and 25, saw what it got. But I would have guessed B or C. Just blindly guessing. Okay. Are there any questions about our ACT rant for the day?
Are these gonna be our deal maker?
We're going to do at least 3 or 4 ACT problems every day until we die. Yeah. Yes, we're going to do it with lowering your time. Yes, dear.
Can we put the date up on it?
I wouldn't. So Natalie's asking about this. I would put the date we covered it on, just for reference. So I can classify it on numbers. We're covering that on 8/11. So I would probably put the date beside it. But again, when Natalie thinks she's got that, like she knows she can do it, she's her own person. She can put her own check mark. And that way, if Natalie never really gets that, we can come back to it and say, hey, Natalie, you never put a check mark there. That's not your thing. Okay, you all picked up a giant packet of notes on your way in. Let's look at that giant packet now.
No, it's not a giant. No, it's like a giant. It's a mega.
Yeah. See, this is how you would be losing points, because you know we can't have that much in between. We gotta move on, because we gotta get 2 more things done. Okay, so today we're trying to cover 2 different topics. They don't have anything to do with each other, or at least besides the fact that they're math. They don't have anything to do with each other. So we're going to do a little number theory, and then we're going to do some practicing evaluating expressions. And I hate to break your heart, but all of chapter 1 in all of chapter 2 and all of the first couple chapters are really review of stuff you should already know. So we're going to move pretty fast, but again, most of this you're supposed to already know. It's just been a while, you need a refresher. Okay, you might not know some of the real number stuff, but you know how to solve an equation. You know your order of operations. Okay, so today the first thing we're going to talk about is something called a set. I know it sounds like a sport term, but it was a math term first. A set is it consists of several different types of numbers. So we've got rational numbers, which can be expressed as a ratio, or they look like a fraction, A over B, where A and B are integers and B is not 0. And then I'm going to go ahead and look at the examples with rationals before we move on to a different kind. An example of a rational is like 0.125 or negative 7 over 8 or 2/3. And we're actually very picky with our rational numbers because I've skipped a sentence and it's probably the most important sentence of the day. The decimal form of a rational number is either a terminating or a repeating decimal. What does terminating mean? It has a set end, like 0.125, then we were done. It got terminated, it ended. It has a set end. Repeating means it keeps having the same pattern. For instance, maybe I'll add something to this list, 0.131313. You already can guess what's going to come next, right? What number would come next?
1,
And then
3.
exactly, and we already know what the pattern's going to be. That's a rational number. And if you ever see in a math book, it might be represented with a Q, and they might write something funny in it. Like they're trying to make it super bold or something. We spend a lot of time with rational numbers. But we also spend a lot of time with their friend, the letter I, which is obviously irrational. The opposite of rational is irrational. That makes sense? And the decimal form of an irrational number neither terminates nor repeats. So it doesn't end, it doesn't terminate, but most importantly, it does not repeat. And you're like, surely, eventually it repeats. No, it does not. In fact, you already know quite a few irrational numbers. They already have buttons on the calculator for them. For instance, your favorite irrational number, pi, is 3.1415926 something something something. Guess right, it never starts over again. It's never 314159 again, ever. In fact, if you want to Google it, because you're just kind of a nerd and you want to know things, you can Google my birthday in pi, and at some point, 0512, that's my birthday, May 12th, 0512, that list will come up in pi. And at some point, your 4 digits for your birthday come up in the number pi. It never ends and never repeats. It's crazy. And then there's another button on your calculator that's also an irrational number that we could add to this list. Does anyone know another button on their calculator that's supposed to stand for a number? It's a letter. Yeah, it's E. Not you. Someone in the back said it, Natalie, sorry. It's E. I wrote it as a cursive E. If you want to write it as a normal E, you can. We will spend time on E second semester. It's 2.17, and there's a lot of other stuff with it. All you really need to know is, like pi, it's special. Never repeats, never ends, goes on forever. There are not that many irrational numbers.
You said it was 2.17.
Yeah, it's 2.17, then you're going to ask me what it is after that, and I didn't memorize it the way I did pi. You know, a lot of people memorize, like, how many digits of pi can they memorize? And then I said there are not a lot of examples, and clearly I need to read my own notes, because the next sentence that I should read says, square roots of numbers that are not perfect squares are irrational numbers. So, for instance, the square root of 7 would be an irrational number. Would the square root of 9 be an irrational number? No, because 9 is a perfect square. Would the square root of 10 be an irrational number? Yes, because 10 is not a perfect square. So there actually is a long list that I'm not thinking of. But the most famous are pi and e. Okay, so they have this cool chart over here that shows how the world is. So everything that we talk about in here, until we get to the world of imaginary, which is not happening anytime soon, everything we talk about in here is called a real number. Like you have a real friend, not an imaginary friend. Everything in here is a real number. So everything's a real number. And then we got this world of rational ones, and then there's the world of irrational ones. That's why there's a line, because they don't mesh. You're either rational or you're irrational. And then apparently there are a lot of subsets of rational ones. Okay, so for instance, it says the set of integers. So integers are just like counting numbers, but we can go negative. That's what's going to be special about integers, is that it's still, and I would write that note to myself, still includes negatives. I just put NEG for negative. So negative 325 is an integer. Notice that I said negative 325, not negative 325.5. We're not talking decimals. We're not talking fractions. We're talking normal numbers, but positive or negative. And then your favorite kind of numbers are what they call, so we just talked about integers. Your favorite kind of numbers are what we call whole numbers, which don't include negatives. And then a subset of those are called natural numbers. Can you guess the difference between a whole number and a natural number? Because they sound pretty similar. Why don't you look back at the top, look at the list that goes with whole numbers, look at the list that goes with natural numbers. What is the difference? Yes, dear?
Whole numbers include positives and negatives, and naturals just include positives?
No, so integers include positives. That was good. Integers include positives and negatives. Whole numbers and natural are all just positives, but there is a difference between them. Yes, somebody, tell me what
Whole
it is.
numbers can go all the way back to negatives, right? And the natural numbers.
No, that's what he's saying too. It's 0. Notice, okay, so look at our list. It says integers have negatives and positives. It says whole numbers. Notice there's that 0. And then natural numbers starts at 1. So that's the difference between a whole number and a natural number, is that one thing, 0. He's always in the way. Okay, we call them natural numbers because they actually happen in nature. Like, back in the day, way back in the day, that I will trade my 2 cows for your 1 pig. You would never trade 0 cows. That's why they're called natural numbers. I'm not going to give him 0 cows for my 1 pig. That's not going to happen. So natural numbers are ones that just happen naturally. And that's why we came up with counting, because we needed to trade our stuff. Okay, we are going to skip that bottom little fill-in thing. We've already got some examples. If you want to transfer your examples to that bottom thing, you can. I know people can't stand blank stuff. Totally get it. Totally get it. Now flip to the back for me. What we're going to do is we're going to classify exactly where each number belongs. So, is it a whole number? Is it a natural number? What is it? So, if you want to, and you don't have to tear it apart, but you can. Lucky me, I have both, so I can put both on the same time. Here's our list of what it means. Our first problem says negative 185. Negative 185. So it's going to be just an integer. It's not a decimal, it's not a fraction, but it's not only positive, so that's why I'm going to say it's an integer. So it's z for sure. So number 1, I would put z. But then back to our chart, z is really a subset of q. Like z is living inside the q square. And then Q is really living inside the R, the real numbers. So yes, it's an integer. But if you're an integer, you're automatically going to be rational, and you're automatically, no matter what, you're going to be real with us. Unless we start talking imaginary, which is not happening today. We're not in the I land yet. Okay, and then our next example is a fraction, so it's 4/9. Looking back over on my paper, integers don't involve fractions, whole numbers don't involve fractions, natural numbers don't involve, but rationals do. If you want to put a regular Z, a regular Q, a regular R, you don't want to make yours fancy like me, you do not have to. I will not be mad. Okay, but back to this chart again. The Q, those rational numbers, they still live inside the real number. So I promise, I don't see a single problem we're going to work where I'm not going to say it's a real number. Okay, and then we get to the square root of 95. And now we're into an issue because I don't know. I'm going to have to type it in my calculator and see, does the decimal repeat or does the decimal not repeat? Does the decimal terminate? I appreciate the person in table 4 who's already typing in their calculator for me. She's going to tell me, and that would have gotten her group a point. It doesn't repeat. It doesn't repeat at all. Okay, so if it doesn't repeat, what does that make it? Rational or irrational? It makes it irrational, which was the I, so finally we get to write something else. And the reason was put because it doesn't repeat. But if we look back at that chart again, the I, those irrational numbers, they're still inside the real number world. So we're still going to put R. Yes, dear.
If we were like taking the test, would you want us to put both of those or just the main?
Just the main one would be fine. That's the best question I've had all day. He would have redeemed that point he lost earlier right then. The main one would be fine. If you just wanted to put the main one of just the Z, just the Q, just the I am not going to be mad at that. I'm not. Now, could you be like me and try to list them all? Yes, of course. Okay, and then we get to 5. And now 5, we got a whole list of things we could put. What is the smallest I can put with 5? Natural, because it comes up naturally. So I'm going to put the N. And if he's only wanting to put the one thing, he can just put N. But if he's wanting to make the whole giant list, he can put the N, the W, the Z, the I, and the Q. He can put it all. Not the I. Jeez Louise, it's not the Q and the R. You can't be both Q and I. So if I were to make a note to myself of what not to do, whatever you do, don't put the Q and the I together. They can't be both at the same time. Okay, now I feel like I probably rambled and it's 9 o'clock on the nose, of course. Let's see. I'm supposed to finish 5 through 8, so we'll finish those quickly. And then your homework is supposed to be page 5. Let's look at it. Can you still do it? 5, 1 through 12. Yes, you still can. So let's finish these last 4. That way you're for sure on the right page, and it doesn't even change your homework that Ms. Compton talked too much. Haha. Sorry. Bless your heart. Okay, we get to number 5, and I'm tricking you. Why am I tricking you on number 5? How am I tricking you? What is the square root of 121? 11. So it's actually not even got to do with the square root. It's a normal number. It is a natural number. It would have came up naturally. You could have traded those 11 cows. So it's natural. It's whole. Clearly it's an integer. It's rational. And it's real. It's got that exact same list as number 4. But it was a little harder than number 4 because I had untricked you. Because you had to think through in my head, hey, something's going on. Okay, and then we get to number 6, and it says 625,738 is my decimal. Okay? Clearly, since it's a decimal, it's not natural, it's not whole, and it's not an integer. What is it? It's either got to be rational or irrational. Why is it irrational? It doesn't repeat. It didn't say 625, 625, 625. It doesn't repeat. So it's irrational, but it's also real. So it should match your answer from the last one we had like that was number 3. Okay, and then I go here again, tricking you.
Teacher, students, at this time, may I please have all sophomores to the auditorium? Please release all sophomores to the auditorium.
My sophomore babies, I swear you need to copy these 2 down tomorrow on Monday. I'll put them up first thing for you. Number 7, I'm tricking you again because 24 over 8 reduces to 3. So really it's a natural number. Why I put it in the weird list order, I don't know. I was in a hurry. And then 0.37, it's going to keep repeating. It's going to be 0.37, 37, 37. So again, I know this is silly, but you just got to ask yourself, is it going to repeat? Is it always positive or negative? Is Ms. Compton tricking me? Would it simplify? It's really not that hard. And as Seth pointed out, because he is pretty smart sometimes. I mean, he did pack up while I was still talking, so that, you know, I can't brag on him that much. But if Seth wants to, if he just wants to put the main letter of the smallest that it could be, I'm not going to be mad that he doesn't have the list of 5. My God. If he just put natural, I can't be ugly. Do you think I'm going to check those 12 problems on Monday?
Yes.
I am. Of course I am.